Hey guys, in this video I'll be showing you how to derive the value of pi using Monte Carlo method. So first I'm going to show you some basic diagram of how this is going to work. So imagine we have a square and inside the square we have a circle. So just assume this is a perfect circle. And now the circle obviously will have some radius which we will call r. Now so if we were to have two r's, it would be the full side of this square. So it'll be r and r. And since this is a square, which obviously I cannot draw, this will be the same. So this will also be 2r. So to find the area of the circle, we simply have pi r squared. And to find the area of the square, it's simply 2r times by 2r, which is simply pi r squared divided by 4r squared. Now since r squared is common on both sides, we just cancel it and we're left with pi over 4. So now what is pi over 4? It's the value we get when we compare the ratio of the circle to the square. So it's just simply we'll just call it area ratio. Okay, so now I will walk you through how to implement this in Python, and all we have to do is multiply the area ratio by 4 to get pi. So that will give us our pi, or approximate pi. So first I'm going to import some libraries which will make our life easy. Import numpy as mp, and we're importing this just to make our life easy when we're square rooting a number. I will import matplotlib.pyplot as plt because so I can show you what I'm doing visually. And I will also import random, which is the most important thing here because Monte Carlo works on the basis of randomness. So first I'll have some variables I'll have inside circle, and I will initially set this to 0. And next I will have iterations. Now iteration is how many times we want to iterate, or how many points we want to have. In fact, I'll call it points. So the more points you generate, the more the accurate you will be because of the law of large number. That's just how Monte Carlo works. Now we will have for loop. So for I in range points, so we go from 1 to 1,000. What do we want to do when we go through each point? Well, we want to generate an x value and a y value. So x equal random dot uniform. We want a value between -1 and 1 because we have a radius of 1. We've assumed a radius of 1. It will make our job easier. You can do it with whatever you want, but this is the most simplest way. And we'll also have the same for y. Okay, so this will give us 1,000 x's and 1,000 y's. Now, what I want to do, okay, so next we will simply compare the y's and x's to see if it satisfies the equation of a circle, or if it falls within the circle. So we will see if the points fall here, here, inside the circle or in there. We know the circle equation of a circle is simply y squared plus x squared equals r squared. We've already said r is 1, just to make our life easier. So we simply want to check if the sqrt of that is less than 1. If it's less than 1, then it means we are inside less than 1 inside the circle, and so we will add a point to the inside circle. So if np.sqrt x squared, this is a simple way of squaring in Python, plus y, no, it should be in here, shouldn't it? Plus y square is, in fact, I don't really need this, is less than 1. What do we want to do? Well, we want to add a point to the inside circle. So that way we can compare the ratio inside circle equal inside circle. So what it is for each iteration plus 1. And I will also plt.scatter. I will scatter the points x and y, and I'll color it, let's say, blue. No, actually red. Now what do we want to do if it doesn't satisfy this criteria? Well, we'll just simply have an else statement. This will be anything else, but we know because of how we defined it, it'll be either this or outside. It'll either be in the square or in the rectangle, square. It'll either be in the circle or in the square, excuse me. So now we'll do plt.scatter. All we're doing is scattering it, but in a different color. Let's say blue, because red and blue go well together. So now just to show you visually, come on. Okay, so this is basically a circle, and blue are the rectangle. And now we know from our area ratio, which our area ratio equals 4 over pi. So therefore pi equals area ratio equal times 4. So let's look at area ratio. What is our area ratio? Area ratio equals, well, what does it equal? It equals, so inside circle, the points that fall inside the circle divided by the total points. That's it, isn't it? And now to find pi was ratio. Okay, I don't know why that's red, but area ratio. Okay, so now we will look at estimate of pi equals 4 times area ratio. Okay, so that should work. Now let's look at that. I should have printed it as well. So print estimate of pi 3.144, which is very good. So if I were to reduce these points and look at my estimate again, it's 2.96, which isn't that far off, to be fair, but it's still not 3.14, is it? So now if I were to do for this for let's say 5,000 or 10,000, it will take ages. So I've already done it, but you'll get more refined. You'll get more closer to the pi value. So I've already done that here. I've done 10,000 points here. This took ages, but it's basically the same thing. It gave me a value for pi as 3.1404, and the actual pi is roughly 3.14159. So that's not that bad, and that's how you simply use Monte Carlo to estimate the value of pi. I hope you like this video, and let me know if you have any questions about this. Now remember, with this, it's the more points you have, the more accurate you will be. Okay, so thank you.